Alright, this is Mr. Gillum, and today what we're going to do is factor trinomials with leading coefficients. And how we're going to do that is we're going to use grouping. Okay, so what we've been practicing is factoring by grouping, where we have four terms. Whatever those four terms are, we would separate them into two parts, and we would find the GCF of each part. Okay, so today what we're going to do is we're going to take three terms, and we're going to separate it into four terms. And then we're going to be able to factor the trinomial much easier. Okay, so this is a strategy that we're going to employ here because it's going to be easier than trying to figure out a guess and check method, because that's our other option would be a guess and check. Okay, so what we're going to do is we're going to modify the trinomial, meaning the three terms. Okay, so we're going to have like an x squared plus 2x plus 1, but instead of just being like that, what we're going to do is we're going to have a number in front of x squared, so everything's going to change a little bit. And so what we're going to do is we're going to change three terms into four terms. And then, I guess first what we're going to do is we're going to have to multiply the first term with the last term. So I'm going to multiply these numbers together. Okay, and I'm just going to write that number up here. And what I'm going to do, similarly to when we were first factoring trinomials, I'm going to list all the factors. So, 1 times whatever, and all these different factors. Okay. When I find the factors that work that add up to the middle number, what I'm going to do, instead of making my two parentheses, I'm going to actually replace. I'm going to take out the middle part here. I'm going to put in two different terms for it. Okay, I'm going to separate the middle term, the linear term, into two parts. Okay, and then I'll have four terms to factor by grouping. Okay, so now the instructions are never as clear as the first example. So let's take a look at our first example here, and we'll see if we can do a nice job. If I was trying to factor these, the old-fashioned way would be what two numbers multiply to get -3 add up to -20. But when we were doing it like that, there was never a leading coefficient, and if there was, we were able to take out the GCF. So I guess I should always emphasize that if there is a GCF, always try to take that out first. In this case, I see that 7, 20, and 3 don't have any numbers that they share in common. There's no common factor. So what I'm going to do is I'm going to try this new strategy. Okay, I'm going to take -3 times 7, and I'm going to call it -21. Okay, and so unlike before, where I would just use the -3, now I'm using the 7 and the -3. So I'm looking for factors of -21. Okay, so when I multiply to get a negative number, I can have the positive version or the negative version. So I'm going to write both versions down on my paper. I have -3 times +7, or 3 times -7. And I think that's all of them. So I only have four choices. And the choice I'm looking for still is what I'm looking for is this middle term, trying to get it to add up to -20. -1 plus 21 would be +20, so I don't want that one. 1 minus 21 is the one that I want. Now here's where things change, and the reason they're changing is because of this leading coefficient. It's making it more difficult for us to factor. All right, so what we're changing now is we are instead of writing our two parentheses like in the past, and we're starting out with the x squared and all that, what we're going to do is we're going to separate this into two parts. I'm going to say 7x squared, it didn't change. And instead of -20x, what I'm going to do is I'm going to say plus 1x minus 21x minus 3. Okay, so I've separated the 20x, the -20x, into a positive 1x and a -21x. It's still -20x together, but the nice part about this is now I can factor by grouping. So what I'm going to do is I'm going to separate this into two parts, and this negative just goes with the 21x, so I'm going to put that negative inside the parentheses there with a change. Now I'm looking for a GCF in each of the little parentheses. I see that 7x squared and x have an x in common, leaving me with a 7x plus 1. Now the 1's important because I need to make sure when I distribute, I have what I started with. Now I put a plus sign, but really what it's going to be is a minus. We're going to change that. I see -21x and -3 both share -3 in common, so that's what I'm going to pull out. I always want my first term in the parentheses to be a positive. So that leaves me with 7x plus 1. So as you can see, if I factor by grouping, I'm now able to factor x minus 3 times 7x plus 1. And so I was still able to get my two parentheses that I was shooting for. The problem that was preventing me was this leading coefficient. But now I've worked around that. I can factor by grouping and can still get to the same output that I'm looking for. The two factors of 7x squared minus 20x minus 3 are x minus 3 and 7x plus 1. All right. The other alternative is guess and check, which takes a lot of time because you have to double distribute over and over and over until you find the correct combination of terms that you're looking for. So I think this is why we practice factor by grouping. This way is going to be much more efficient for us. Taking a look at the next one. Let's do it in a different color so we can make sure we know the one from the other. I'm going to start by multiplying the constant with the leading coefficient. 5 times 3, which is 15. Okay, so what I'm thinking is what numbers multiply to get 15? Now I see that they have to add up to a positive number, so I'm just going to write positive numbers down. 1 times 15 or 3 times 5. I don't need to write down 5 times 3, it's the same thing. I'm looking between these two choices that I have. I only have two choices. Which one is going to add up to 16? Well, you can probably tell right away that 1 plus 15 is going to equal 16. So here's where things change. Instead of just going straight to this, that's not what we're doing. What we're doing is we're separating the middle term, the linear term is what they call it, into two parts. The 5z squared doesn't change, but the 16z is now a 1z plus 5, 15z. And I don't change my positive 3 either. All right, so I have 4 terms now instead of 3, but really these middle two terms are the same as the 16z. The nice thing about writing it this way, though, is I can factor by grouping. So now, if I look between 5z squared and z, I can pull out or factor out a z. Maybe we have 5z plus 1. And between 15z and 3, I know they share a positive 3, so I can write positive 3, and that leaves a 5z plus 1. Luckily, we have a 5z that they share in common, so I can factor him out, and that leaves me with a z plus 3 for my second parenthesis. All right. So what we're doing is we're starting with the trinomial, and the reason we're changing how we're doing this is because of the leading coefficient. When you see that there's a leading coefficient there, and there's nothing to take a greatest common factor from, then we have to use this new roundabout way of factor by grouping. All right, let's take a look at a few more. And ooh, I threw some negatives in here again. Like I said, I do want to emphasize, if there is a greatest common factor, make sure you take that out first, because then all the numbers will be smaller, much easier to work with. Looking at either of these problems, I don't see a greatest common factor to take out, which would be like if I had a 2, then I'd write everything again. Okay, there's not that. None of those things are going to happen this time. 3, 5, and 12 don't share a factor, and 4, 9, and 2 don't share a factor. So what we have here is the problem is this leading coefficient. And so we're going to have to factor this by grouping, but to do that, we need to figure out what we need to change the 5x into. So before I begin, I want to multiply the negative 12 and the 3 together. 3 times negative 12, negative 36. Now there's a lot of factors of negative 36. You need to add up to a positive number. So I'm going to start with just writing them all down. And the more we do factoring, the quicker you'll be at writing them down. Let's see here. 5 doesn't work, 6 works. All right, and that's all of them. I have a lot of choices this time. The choice I'm looking for is the one that adds up to 5. So in this case, I can skim all the way down. Looks like negative 4 plus 9 would equal positive 5. So now instead of making my two parentheses like I have in the past, I can't do that anymore because of this leading coefficient. What I'm going to do instead is I'm going to write down the leading term. I'm going to separate the 5x into a minus 4x and a positive 9x. The negative 12 is not going to change either. So I've separated my 3 terms into 4 terms by moving out the middle term into 2 parts that are going to equal the middle term, just so I can factor by grouping. I like it when it says plus here because I don't have to do the change rule. Now when I factor, I'm looking for the 2 parts that they have, or what they have in common. Usually there will be a variable that they have in common, 3x minus 4. And here I see that 9 and negative 12 have a 3 in common, a positive 3, 3x minus 4. So once again, you can see that our 3x minus 4 is what they share in common. And if I remove the 3x minus 4 from both parts, I'll be left with the x plus 3. And so there's my factoring. Okay, like I said, and you can always double check to see. We could redistribute 3x squared plus 9x minus 4x minus 12, and we could check to see, okay, yep, there's my 5x, there's my 3x squared, there's my negative 12, and I can make sure I'm doing it correctly. The factoring part itself would be separating the trinomial into the 2 parts. Let's take a look at another one here. Once again, after 3 examples, I'm going to move a little bit, teensy bit faster this time. this 4 is telling me I can't just go straight away to factor two parts. What I'm going to have to do is I'm going to have to separate this and factor by grouping. Take 4 times 2, 8. And so numbers that multiply to get 8 and add up to -9, 1 times 8, 2 times 4. Okay, here's the problem. If I only do positive this time, 1 plus 8 won't equal a negative, 2 plus 4 won't equal a negative. So what I need to do is I need to do negative numbers. I know negative times a negative is still a positive, but luckily for me, it'll add up to a negative. So I'm going to say that -1 times -8 will multiply to get 8 and add up to -9. So like I said before, we're not just separating into two parts now, we're actually separating the linear term into two parts. 4x squared and positive 2 do not change. I'm separating the linear part. Make it -x and -8x. Now I have this nice problem where I can factor by grouping. I have 4 terms. It's the same amount as my original expression. I'm going to go ahead and separate that into two parts, and when I see that minus, I need to do a change. If I take the x out of the beginning, I have 4x minus 1. And in this case, like I said, I want this first term to be positive, so I'm going to take a -2 out. And that's going to leave me with a 4x minus 1. If I only take a regular 2, it's not going to match in the parentheses. And if the parentheses don't match, I'm not allowed to factor farther. So what I'm going to say is for total is 4x minus 1 is what they share in common. And that leaves us with an x and a -2. And there we go. We factored it. You can always check your answer by double distributing. There are going to be some that don't factor, and I believe this might be one of them. But we're going to start again. 4 times 5 is 20, and we'll just see if we can figure it out. My choices are 1 times 20, 2 times 10, 4 times 5. Now, if we don't see anything that adds up to 12, then we're in trouble. But luckily, I might have been wrong, 2 plus 10 would equal 12. Okay, so we're in good shape. I'm going to go ahead and keep the 4u squared. I'm going to write down plus 2u plus 10u plus 5. Okay, these guys were replaced with my 12. So now I'm going to factor by grouping, and I like having that plus in the middle because I don't have to change. I see that these front terms have a 2u in common, leaving me with a 2u plus 1. And the back terms have a 5 in common, 2u plus 1. It's like magic. Terms match. So 2u plus 1, and that leaves me a 2u plus 5 for my second parenthesis. All right. So today is different than when we first factored trinomials because of this one specific reason. We have a we have a leading coefficient. There's no greatest common factor between 4, 12, and 5. So if we have a leading coefficient, before we start our parentheses, we need to separate it into grouping. All right, so that's it for today. Factoring by grouping after separating it from a trinomial.